Okay, so my name's Dan Walsh. I'm going to do it's going to be a little different than the previous two because I'm not a sysadmin, I'm an engineer. So I gave a talk at Docker5 on Docker security. What I do for Red Hat, over the last 10 years, I'm the SE Linux guy at Red Hat. But for the last year, I've been working on, well, the last few years, I've been working on container technology. Container technology prior to Docker. And then almost a year ago, about 9 months ago, in September, all of a sudden we started noticing Docker coming on the scene. We were working on a competing project called Libvirt Sandbox, which is a mechanism for containerizing applications, but it's basically just taking your operating system and splitting it up, making it really easy to containerize and run lots of applications, but also sharing the user of the operating system. We quickly noticed that Docker was really taking off in the open source world, and Red Hat at that point decided to you can't beat them, join them. So we jumped in both feet forward into working on Docker and really trying to get Docker into what we consider enterprise quality. So Red Hat really started working back in September, and if you went to the Red Hat Summit or heard about the Red Hat Summit, one of the biggest news at the Red Hat Summit was the release of RHEL 7 and Docker. Docker was a huge, important feature at the release. And I'm going to talk about some of the engineering work that we've done in it. As I said, I gave a talk at LinuxCon on Docker security. You can actually see it online right now. Docker has it on their page. You can listen to me drone on about security. One of the main features I like to say when I talk about Docker, first of all, is that containers don't contain. So anytime if you're looking into containers, don't think of them as necessarily as being a security mechanism, although we're trying to improve that. And anybody that tells you that Docker contains is kind of fibbing at you a little bit. Okay? What I mean by that is if you're running a privileged process inside of a container, treat that as a privileged process outside of the container. And we're trying to add all these technologies to wrap around it to make that statement no longer true, but at this point I would still say that statement is true. So let me get So, anyways, what Red Hat's been doing, we came out with this new project called Project Atomic, and this really is sort of the Project Atomic is sort of the focal point of all efforts around Docker inside of Red Hat. You can see some of the technologies that we're using around container technology and stuff. So we're looking at how do we get sort of the traditional RPMs to work well and to help you build Docker containers. How do you make it efficient for creating these? There's been a couple of people who have talked about how do you manage containers? How do you manage making sure the container's running on your system? So everybody here familiar with System D? Nobody's ever heard of System D. How many people have played with RHEL 7? Oh, Fedora. Okay, so a few of you played with it. Okay, so System D is the replacement for the Sys5 init system that's been around for the last 30 years. So in Fedora over the last few years, we've been developing this brand new init system called System D. It's really, really cool and it can be really, really scary for most of you. Okay, so when you really know how to deal with init scripts, it's somewhat of a change, but everybody, I believe, after you work with System D for 6 months, you're going to fall in love with it. The first 6 months, you might not like it so much. But System D is a new init system. And for all those people out there that are saying Ubuntu has Upstart, guess what? Ubuntu has announced that they're moving to System D. So the entire world of open source software in the future is going to be built on a new init system called System D. What System D can really do is very efficiently start and stop services. System D is all about managing services, managing C groups, managing your infrastructure around running an application. One of the ways I look at Docker containers is just a fancy way of running a service. So everything that's been talked about so far is sort of been container-centric. I like to look at it the other side. This is just another entity that you're going to run on top of your operating system. That's just a system service, and it happens to be a really fancy way, a really nice way of running services in your system, but you really need to have something that manages your system services, and that's what a system is. Another product we have coming out is something called Gear-D. Gear-D is came out of the OpenShift effort. Who here has ever heard of OpenShift? Okay, so a bunch more of you heard of OpenShift. OpenShift is actually a huge system for managing containers. Okay, most people think of it as an app server, but basically in OpenShift world, what we have is hundreds of thousands of users that are logging onto the system. Some of them are bad people, some of them are good people, right? Everybody can get on the system for free and basically try to interfere with each other. So what we've done over the last 4 or 5 years since we've put up OpenShift is try to containerize all those users. And we're using technology like SE Linux, C groups, other type of technology to containerize them. So we have a lot of experience taking advantage of the container technologies. And guess what? With Docker, we're now moving Docker to run inside of our OpenShift environment. So we're now making OpenShift work with Docker. And one of the technologies, the team that's working on OpenShift is working on Gear-D, which is all about orchestrating or getting different containers to work together. And also looking at plugging in the gears into systemd so that systemd becomes the manager. So how does it start? How do you have, when your machine boots up, how do you make sure your Docker containers are running? If a container crashes, how does, what make sure it restarts? Who's watching your containers? Who's monitoring the system? That would be systemd, but then you can use Gear-D to start to orchestrate. How do I connect different containers together? How can I connect containers of different hosts together so they can intercommunicate? So that's where Gear-D comes in. SE Linux and other technologies are all about containing the container. Okay, how do we make sure that the containers do not interfere with each other from a security point of view? So finally we get into Project Atomic. So if we look at Project Atomic, the evolution of the operating system is the delivery for atomic units. So what we wanted to do is we re-looked at the operating system. So RHEL 7 is very much like RHEL 6 as far as it's an operating system. It's probably the best enterprise operating system out there. I think we own about 80% of the paid operating systems in the world, the Linux operating systems in the world. So RHEL 7 is just an enhancement on that. But we wanted to re-look at the operating system as a mechanism for managing containers, right? Basically look at RHEL. So how can we make RHEL 7 an optimal platform for running these containers? So we actually came up with Project Atomic, or the Atomic Operating System. So if you follow it now, there's a new version of RHEL that you can get it, which is called RHEL Atomic. All right? It's just about to come out based on RHEL 7. And really what it is sort of stripped down minimal operating system that you can run. It's optimized for running Docker containers. The beauty of it, though, is it is RHEL. So it's the RHEL 7 kernel, RHEL 7 systemd, RHEL 7, all the services, all the support contracts, everything that you get for running your RHEL, you can now have a stripped down, minimalized version for Atomic. Another interesting feature for it is this thing called RPM OS tree. So one of the reasons it's called Atomic is what we wanted to do is not only make it optimized for running Docker containers, but we wanted to allow you to update the operating system that's running in your Atomic operating system without interfering with the running code. So right now, when you do an update to your system, right, so you have an operating system running and you want to update it, what do you have to do? You have to shut it down, shut down the services, because you're going to update the software and eventually going to reboot to get into the new kernel. So during the process of the update, you have to basically, as I said, shut it down to some known state, update the operating system, retest it a little bit, and then reboot it right into the new kernel. With RHEL Atomic now, we're actually able to update the entire operating system while you're running. Okay, so what happens is that you're actually going to be pulling in updated code onto the system, but it's going to be stored in Colin's in the back of the room, he's the guy that wrote most of the stuff, so I'm going to say in a different image, but that's not quite true. But basically it's like a hard link pool that's off to the side, so it doesn't actually come in and replace the code. So when you update software, usually what happens is the code actually on disk actually gets written out from underneath the processes that are running. So in an Atomic system, we're actually updating the code in sort of a different partition of the disk. So when it's done updating, you have the ability at that point to say, okay, now I'm ready to switch to the new operating system. So say you went from RHEL 7 7.0 to rel 7.1, you install rel 7.1, and you'd be ready to reboot the machine. At the end of the update, you want to reboot to get into the new kernel. As soon as you reboot, you'll be running in 7.1. Okay? Say something went wrong with rel 7.1, it wasn't running properly, the services weren't working correctly. At that point, you can reboot the machine back into rel 7.0. So you'll be able to atomically switch, just by through a reboot, you'll be able to switch from one version of the operating system to the other, and still have your shared content between. So that's where the rel atomic name comes from. And one of the goals here, though, is again, is to keep the operating system as small as possible so that you're not going to have as many updates. And the only thing, in a rel atomic environment, the only thing you're going to be running is the kernel. This is the goal, is the kernel, is systemd, and Docker. There's a journaling system also that we run on it. And then everything else that you would theoretically run in the system is going to be a Docker container.
So essentially enterprise grade CoreOS.
It's it's similar to what CoreOS does. But again, what I like to stress, anytime I talk about this, one of the great things about Red Hat is the amount of effort that we put into the Linux kernel. Okay, and you got to look at like the file system support, the shared clustering, the shared stuff around it, and so having rel underneath the covers gives you all that. As far as again common criteria, all the different government standards, all based, are all still going to be available in rel atomic as well as rel 7. So other parts of Project Atomic. I've already talked a little bit about with SC Linux with mandatory access control, basically looking at how can we take advantage of SC Linux and other tooling to make sure containers stay contained. Gear D is around container orchestration, and then System D is all about robust C group management. Everybody here know a little bit about C groups? Anybody played with C groups before? Okay, again, call is the only one. Okay. So everything that you've heard about with it sort of is explained a little bit about Docker, and people sort of mentioned it. When you're looking at a Docker container environment, you want to make sure that the containers don't interfere with other containers. So that's both from a security point of view, but also a resource point of view. If you have a container that goes wild on your system and starts using up 100% of the CPU, all of your other containers or all your other processes in the system are going to get starved out. Okay, so that's, you got to think about that when you're running containers, or you got to think about that when you're running any type of processes. So the Linux kernel over the last few years has developed a thing called C groups. It allows you to basically carve up resources on the operating system. So you can say stuff like, this process can only have 50% of the CPU. And this other process can only have 50% of the CPU. So you can guarantee that you'll get throughput on it. So in a rel 7 environment, Systemd automatically puts all processes into the C groups. So I'll give you an example of a traditional problem. Say you have an Apache server and you have a MySQL database. The Apache server is out there listening, and Apache service goes off and forks off 1,000 processes. Now you have a MySQL database goes off and forks off 3 processes. The MySQL database is serving content to the Apache processes. So right now you have 1,003 processes on the server. We'll say there was 997 and then 3 processes for it. So you have 1,000 processes running on the system, and the Apache processes are all out there, and guess what they get? They get 1/1000th of the CPU, right? It's just using normal slicing, they're going to get 1/1000th of the system, and then the MariaDBs are going to get 3 out of, they're going to get 3 out of every 1,000 slices in the system on a normal Linux system now. In a C group environment, you're going to put both of those entities, the Apache process into a C group, and you're going to put the MariaDB system into a C group. And now the kernel will divide out the system in such a way that the 997 processes will get one half of the, will get one slice of the system, and the MariaDBs will get one slice of the system. So now you get an even sharing between services, not at the process level, but at the service level. So that's those are things that C groups can start to do to allow you to divide up your system. But a Systemd system, that's going to happen automatically. But when you get to containers, you want to also do that at the container level. So now also you want to make sure that each one of your containers gets an equal amount of system. It doesn't matter how many processes are running inside that container, they get split out. So C groups is a key part of the Linux operating system, Linux kernel, that gives you the ability to take CPU, memory, disk I/O, network I/O, and can basically carve up all those parts of the operating system. And it's a key feature underneath Docker, and it's a key feature inside the system. So what is Red Hat contributing? Red Hat is, I've been a Red Hat for 13 years now, so I'm a big fan, you know, wear the colors and everything, but what Red Hat's really great about is contributing upstream. So when we, a year ago, we weren't working on Docker at all, and if you went to Docker5, I didn't see, who went to Docker5, anybody? Anyways, at Docker5, Red Hat was shouted out as being the #1 contributors to Docker over the last year, and these are some of the people. It's my contribution, but these are all the people that Red Hat has put on Docker. These are the ones that have actually contributed by the patches upstream. We have hundreds of other engineers all working on Docker also with Red Hat. Everything from if you think about what's going to happen with this Docker world, we want to put out RHEL 7 images so that these containers that you build your applications on top of RHEL 7 images. But how do we handle things like security updates to those? How do we handle getting support into containers? We're looking at a higher level of how do we ship applications inside of containers. So if you look at other parts of Red Hat around JBoss, other applications, we're thinking now that the new way of shipping our applications, our higher level applications, will be inside of Docker containers. So imagine you go out to your machine and you say, hey, I really needed the latest version of JBoss installed on my machine. All I have to do is Docker run JBoss. It goes out to RHEL, sucks it down, puts it on your machine, and instantaneously you're running a full JBoss Java beans. You'll quickly know I don't know what I'm talking about when it comes to application services. But basically, you can just pull down these huge, complex applications with a single command. As I just mentioned a little bit, what we feel is it's critical, the underlying operating system that's running inside of your containers, as well as the operating system that you're running as your host operating system, is critical to understand. You need an enterprise quality operating system. One of the things when I talk about the security, in my security talk, I talk about Linux 1999. So if you look at, anybody here been working with Linux back in the prior century? Okay, in 1999, for those young ones in the room, the way you would find software, someone would tell you there's some really neat software out there, and the way you would find it is you would go out and you'd grab a tarball and you'd do a make install. Or you might find an RPM somewhere, and you go out to like rpmfind.net and you would download it on the system. Or you would just, basically you would just go out to random websites. People say, hey, I got some really good code out here, go out to this random website and install your system. This is the way the enterprise, the first versions of enterprises were dealing with Linux. So they went out and did all this stuff, installed all these applications on their box, and all of a sudden they heard about this zlib vulnerability. Okay, so they knew that zlib was an easily hacked piece of code and they went and looked at the system and someone said, do you have the bad version of zlib installed in your machine? And they would have no friggin' clue. Okay, no one would know if they had a bad version of zlib. Okay, so now guess what we are? 20 years later, 15, 16 years later, now we're doing Docker. Okay, and guess what we're doing with Docker? We're going out to random places on the internet and downloading applications, putting them on our machines and saying, Docker run, go ahead. And remember I showed that slide in the beginning that said Docker containers don't contain? They don't. Okay, there's no technology. If I have root on the system, I'm going to take it. I can take your machine over. 3-4 weeks ago, what happened with SSL library? Right? Everybody in the world knew that the SSL library had been hacked. Right? Everybody had to update their SSLs. Okay, so our friend here from IBM has put out 1,000 of these Docker images all over Kingdom Come. Okay, each one of them with their own version of zlib inside of them. Some from Ubuntu, some from RHEL, some from Fedora, some from Gentoo, some from God knows where. You have hundreds of these running on your system, and someone says, do you have the fixes for all your zlibs? Or, not zlibs, OpenSSL bugs. And you're going to sit there and say, no friggin' clue. Calling up Harry. Can someone get a hold of Harry that wrote this application to tell me if he hasn't? Oh, Harry doesn't work here anymore. Where did he get it? He built it in his garage. He built it on his laptop, and then he pushed it out to 1,000 boxes. This is what Docker is providing. So you got to think about this. So this is a reason that you want to deal with something with a known entity backing up your containers. So where did the base image for the container come from? Is it from a company that backs it up and looks for security, has a security response team, will fix the bugs in a reasonable, very short period of time? Do they have tooling to go out and tell you if you have bad versions of OpenSSL? So you've got to think about these things as you go out. And this is why having the base operating system from a supported vendor and having the layered images also provided. So one of the things Red Hat has also done is we're actually working with our partners now to have certified applications. So we will work with third parties to build certified applications, build an application stack, and so the place that you traditionally got your enterprise Linux from will hopefully be the place you're going to get your enterprise. And that's the end of my sales pitch for making sure you pay my salary for several more years. I need 10 more till I retire. So these are some other things we're doing. We're working with our standard tooling to guarantee creating images correctly. We're also working with the Fedora community, putting some of our best ideas out into Fedora on how to, how we're looking at managing these enterprise content. So we're looking for SE Linux as a separation mechanism to control what happens with a container. We got this patch upstream about a month ago, and it's sort of our best effort at this point to contain containers. We ought to actually have, if you go online and watch my video, you'll see probably 20 different other things that we're doing also to contain containers. We're hoping to have this, and I'm not going to get into user namespace, but that's actually something else that we're looking to add technology to also contain the containers.